Well, hi boys and girls. Today we're going to learn how to write the equations of lines that are tangent to curves. And so we're going to start with a little review of how do you write the equation of any line. There are two things you need to write the equation of a line. And those things are a slope and also a point. Now back from Algebra 1, you guys have talked about slope as m and your point has been, an x comma y. We are going to interpret slope in calculus at a point as f prime at that point x. So your equation that you're used to, the old point slope formula, was y minus y1 equals m times x minus x1. And this is how you wrote the equation of a line. And your point, you got your x and your y. I guess I could have called that x1 and y1. And your slope, and you plugged them in. The calculus version of an equation of a tangent line is going to look very similar. It's going to be y minus y1 equals, instead of m, we're going to write f prime at the point x1 and then times x minus x1. And you can even add y1 to both sides and you can get y equals y1 plus f prime at that point x times x minus x1. And on top of that, we can even clean this up a little bit more, and our tangent line equation is y equals f of a, where a is the x coordinate we're trying to write the tangent line at, and f of a is another notation for the y coordinate, remember, plus f prime at a times x minus a. Any of these versions work. If you just want to stick with this version, and if you just want to say, hey, I know how to find m is the derivative, m is the slope, so then you're fine. Any of these versions work. Let's go take a look at some examples. Before we do that, I want to show you what a tangent line actually looks like. So here I've got the graph of the square root of x, and miraculously I happen to know the equation of the tangent line to the square root of x. And so I'm going to graph this, and you're going to see what a tangent line looks like. So there's the graph of the square root of x, and that tangent line touches x at a specific point, and that point is the point 1 comma 1. And you can see that it's tangent. At this point, they share the same slope and they share a point. The same slope and a point. So let's go take a look at an example. Find an equation for the tangent line to the graph of f of x equals x plus 1 at the point where x equals 3. Well, the first thing you're going to want to know is, what is this ordered pair? You need an x and a y. So you need the y coordinate. They tell you x is 3, but what is y? And that's very simple. You want to find f of 3 by plugging 3 in for x, and you get that that's the square root of 4, which is 2. So we have our y coordinate. So we've got our point. What are we missing to write the equation of a tangent line? We need the slope. And how do we find the slope? We need f prime. And where do we want f prime? We want f prime at 3. Now yesterday, unless you're a specific table, or some people at my table in my 4th period, everybody learned a nice little shortcut because they came to class to learn. And this nice little shortcut was, we can find the derivative by rewriting this as x plus 1 to the 1/2. So what do you think f prime of x is? Well, if you know the shortcut, this is 1 over 2 square roots of x plus 1. If you don't know the shortcut, well, you better learn it quick. Alright, so there's f prime of x, and so we want f prime at 3, I guess I'll say f prime at 3 equals 1 over 2 square roots of 4, which is 1/4. So we now have a slope. So let's plug it into our equation. I guess I'll use the basic equation here. Y minus y1 equals m, which is really f prime, or the slope, times x minus x1. And that's the equation of a line that is tangent to the graph of the square root of x plus 1, which we could write that as 2 plus 1/4 times x minus 3. Let's go see if we're right. Let's graph it and see if that line really is tangent to the graph of the square root of x plus 1 at the point where x equals 3. So we'll go back to our y equals, and we'll call this the square root of x plus 1. And our tangent line equation was 2 plus 1/4 times x minus 3. And we're going to see if this really is tangent out there when x is 3. Well, there's x equals 3, and I can definitely believe that right there at 3, they share a point, they share a slope, and that's the tangent line to the graph. Let's go do another example. Write the equation of the tangent line to the graph of f of x equals x to the 4th minus 7x squared plus 12 at the point where x equals 1. Well, if you're going to write the equation of a tangent line, you need two things. You need a point and you need a slope. The point is 1 comma f of 1. You have to plug 1 into that equation to get the y coordinate. So we need f of 1, and if we plug in a 1, we're going to get 1 to the 4th, which is 1, minus 7 times 1 squared, so that's just 1 minus 7, which is negative 6, plus 12 is 6. So that's the y coordinate. The next thing we need is a slope. And how do we find slope? We find that with derivative. And how do we find derivative? Well, hopefully yesterday you learned the shortcut, because if not, you're in trouble. So we need to find f prime, and f prime would be 4x cubed minus 14x. And we want the slope at the point where x equals 1. So if you plug in 1, you're going to get 4 minus 14, which is negative 10. So I now have a slope and I have a point. So my equation of my tangent line is y minus y1, which is your y coordinate, equals the slope times x minus x1. And of course, you could rewrite this by adding the 6 to both sides. 6 minus 10 times x minus 1. Let's go take a look at one last example that's not the equation of a tangent line, but it is asking you for the slope, which is just an application of the derivative. This says if we did have a tangent line to this graph, what would the slope of that line be? This simply wants me to find f prime at that point 1. So what I'm going to do first is I'm going to distribute that 2x through, and I'm going to make it 4x cubed minus 2x. And so if you plug in a 1 into the derivative, well, we're going to have to find the derivative first. So we want to find f prime of x. And since we know the shortcut, this is pretty easy. That's 12x squared minus 2. So f prime at 1 is 12 minus 2, which is 10. We'll see you guys tomorrow.